We've been talking about data, how to organize and visually represent data. Now we want to talk about something called the measure of central tendency of data. It's in some sense a measure of what the middle of the data is, what the average data point looks like. There are three common measures of central tendency. The first is called the mode. The mode is simply the most frequent number in a set of numbers, and that's easy enough. For example, if I gave you the data points 3383158888, notice that there are 4 8s and that there are more 8s than any other data point. That means that the mode is 8. Now, if two numbers appear equally frequently, we'll just call them both modes. Sometimes we say that distribution is bimodal. For example, if I had the data 77271522, I notice here that there are 3 2s, but there are also 3 7s, and that together those two appear more frequently than any other. So we would say that both of those are modes. The modes are 2 and 7. That's a bimodal set of data. If we have 3 or more numbers that appear equally frequently, we're just going to say that there is no mode. Once you get above 2, it becomes sort of difficult to talk about mode. So we'll say that if there are 3 or more sets of numbers that have the same frequency, we'll just say there is no mode. For example, if I have the data 122543353, 2 appears twice, 3 appears twice, and 5 appears twice. Since there are 3, we'll just say there is no mode. The second measure of central tendency is called the median. The median is the middle number in value with a set of numbers. And in order to find the median, you really need to put the numbers in order. So if I'm given the numbers unordered, before I find the median, I want to put the numbers in order. It doesn't matter if you do smallest to largest or largest to smallest, but they do need to be in order. So once I've ordered these numbers, the one in the middle is the median. So here, the median is 5. Now you might ask, what happens if there is no single number in the middle? If I add another data point to that last set of data and put them in order, what I notice is there's no single number in the middle. Both the 5 and the 8 together make up the middle. What do you do then? And the answer is you simply take the ordinary average of the two middle numbers. So you add them up and divide by 2. So for this particular data set, you get 13 halves, which is 6.5. So the median here is 6.5. So when there's no single middle number, you average the two numbers in the middle to get the median. The third measure of central tendency is called the mean. The mean is just the ordinary arithmetic average that you've been doing for years. You just average the numbers. The mean is very important in the study of statistics, so we want to focus a little bit more on the mean than some of the others. We use a symbol, typically it's an X with a horizontal line above it to represent the mean. And we pronounce that X bar. So an X with the horizontal line above it is read X bar, and it's the mean of the data set. And to calculate the mean, you simply add up all the data points and divide by how many there are. It's the same old average you've been doing for years. I will show a notation, though, that you may or may not have seen. One way to indicate repeated addition is to use the Greek letter capital sigma. And if I write capital sigma x sub I, that just means to sum up or add up all the x's and then divide by n. If you see that notation with the capital sigma, it's just telling you to add everything up. So don't let the notation bother you. An X with a horizontal line above it is pronounced X bar, and it's the mean of the data set. And if you see a sigma in front of the x sub I, that just means add them all up. And then, of course, divide by n. Now, I'm going to make a technical point, and then I'm going to pretty much push it aside. Technically, in statistics, When I say X bar, I'm talking about the sample mean. In statistics, we think of having a population and you draw a sample, a random sample from that population to make inferences about the population itself. So if I were interested in all 18-year-olds in the United States, that would be the population. I might draw a random sample of 18-year-olds, and that would be the sample from the larger population. If I took the average of every single 18-year-old in the United States, I might get one thing, but if I took the average of my sample, I might not get exactly the same thing. One would hope it would be close, but that's the difference between a sample mean and a population mean. That's very important in the study of statistics when you're doing inferences. But we're not really doing any inferential statistics per se here, so we're not going to worry too much about that distinction. But what I will say is, if you're working with a sample, X bar is the sample mean. Mu stands for the mean of the entire population. If you want to talk about the population that you're drawing a sample from, you would use mu. But now that I've said that, I'm going to push that aside because we're not doing really any inferential statistics. For our purposes, we're not too worried about the difference between those two means. But technically, X bar is the sample mean and mu is the population mean. But let's push that aside because that's not very important to us here. Now let's go back to actually calculating a mean. Suppose I gave you this data set, 338315888. And ask you to find the mean and round the answer to 2 decimal places. All you need to do is add them up and divide by how many there are. Well, you can see there are 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you add up each of the numbers and then divide by 9 because there are 9 of them. And that gives you 47 over 9, which to 2 decimal places is 5.22. This might also be a good place to mention that the Casio FX260 calculator that you're using has a stats mode that will calculate these means for you. And let's talk about how that works. In order to calculate the mean using the stats mode in the Casio FX260, the first thing you do is make sure there's no old data sitting in there that might mess up your calculation. There are more ways to do this, but if you just press the on button, that will clear the old data. There are other ways. I typically do it that way. Point is, you have to clear any old data out to make sure there's nothing in there when you start. Then you have to put the calculator in its stats mode. And the way you do that is you press the mode key followed by the period or the decimal point. That puts the calculator in stats mode. Now you have to be sure you're actually in the stats mode before you start, and the way you can do that is to look up in the upper right hand corner of that calculator display, and if you don't see SD in that upper right corner, you're not in stats mode. But if you press mode period or mode decimal point, that will put you into stats mode. But it's a good idea to glance up in the upper right and make sure you see that SD. Okay, now you're in stats mode. Key in the first number. So whatever the number you're trying to put in first, key it in and press the M plus key. The M plus key is in the lower right hand corner. Then you keep doing that. For the second number, you key it in, press M plus. Then the third number, key it in, press M plus, and keep doing that. And don't forget, after that last number, you still have to press M plus. Some people forget M plus has to be pressed after the entry of every single number, even the last one. Now you've got all the numbers in. You press Shift 7. And you don't have to memorize that 7. If you look above the 7, you'll see the little X bar symbol. That's why you're pressing 7. So you're actually asking the calculator now to do X bar. And the number that you're looking for, the mean, will be in the calculator display at this point. That's all there is to it. I will mention a couple of other useful tips. If you want to make sure you entered all the numbers, say there are 10 numbers and you're putting them in and you get to the end and you want to say, did I really enter all 10 of them? If you press Shift 6, it will tell you how many numbers have been entered. So if you press Shift 6 and only see that you entered 9 numbers, you know something's wrong. Or if you accidentally entered one twice, it would say 11. So it's not a bad idea after you think you've entered all the numbers to press Shift 6 quickly just to make sure that you have in the same number of numbers that you think you do. Also, Once a number's been entered in, you can press M plus to enter it again. You're not always going to be given the data in the same form. Sometimes, for instance, you might be required to calculate any of these, mean, median, or mode, from data that's in a frequency table, not just laid out as a list of numbers. So let's look at that. Suppose I gave you this frequency table with different scores and their frequencies and asked you to find the mode of that data. That's the easiest question that you could be asked, probably, because a frequency table tells you how many times each data point appears, and the mode is the one that appears the most often. So if you're given a frequency table and asked to find the mode, all you have to do is look. The number with the highest frequency, in this case 26 has a frequency of 4, that's your mode. So a frequency table is a perfect way to find modes. What if I ask you to find the median of that same data set? Well, first of all, the data has to be in order to find the median. Now, these scores are in order. There's 12, and then there's 15, 17. So they are in order already, so that's good. You have to make sure they are, though, because you cannot find the median without having the data in order. But you do have to pay attention to the frequencies when you're trying to find the middle value. You can't just say there are 7 data points. There are actually more than that, because, for instance, you have 17 appearing 3 times, and 20 appearing 3 times, and 26 appearing 4 times, and so on. So when you're looking for the median, you have to be careful about what the middle is. And I'm going to go carefully through this and show you how you can count it. I know that if there are 15 data points, and there are, if you add up all the frequencies, you get 15. There are 15 data points. If you have 15 data points, the 8th data point is the middle. So we have to get to the 8th one. How do you do that? I would suggest just starting at the top. There's 112, so your count is 1. There's 115, so now you're up to one more, it makes 2. But there are 3 17s, so you've got to count 3 of those, so that would be 3, 4, 5. You've got to count 3 of them. Then you move to the 20s, there's 3 of those, so you get 6, 7, 8. And bingo, you've hit the 8th one now. We know the 8th score is the median, so the 8th score happened to be a 20, so the median is 20. Given a frequency table, if the data is in order, it's pretty easy to find the median, but you do have to be careful about counting those frequencies properly. You could have written out all the data. If there were like 500 data points, you're not going to write them all out. But with just 15, you actually could have written them out in order. There's 112, there's 115, there are 3 17s, there's 3 20s, a 21, 4 26s, 2 32s, and you could have found that the median was 20 that way. But that only works when there's a fairly small number of numbers. Now let's find the mean of that same frequency table data. It makes sense to use the calculator stats mode because it does all the heavy lifting for you. Here are the keystrokes. You do on, which clears the old data. Then you put it in stats mode by pressing mode period or mode decimal point. And then you start entering the data. There's 112, so you enter 12 M plus. There's 115, so you do 15 M plus. There are 3 17s, so you enter 17 and then press M plus 3 times, once for each one. And then keep going. There are 3 20s, so you do M plus 3 times after you type in the 20. There's only 121, so you type in 21 and press M plus once. There are 4 26s, so you type in 26 and press M plus 4 times. And finally, there's a 32 appearing twice, so you type in 32 and do M plus twice. Now all the data is in. Once the data is in, you do Shift 7. Remember, we're looking for the mean, and X bar is above the 7. So Shift 7 will give you the mean. And if you look in the calculator display after having done all that, you will see 21.8. So the mean is 21.8. So we found the mode, the median, and the mean for that data presented in a frequency table. We're always looking at visual ways to show data. There's something called the 5-number summary And it basically reduces the data down to 5 numbers. And the idea is that in some sense, those 5 numbers capture the essence of that data. Okay, what are those 5 numbers, and what exactly do we mean when we say the 5-number summary? Here's how we do it. If we take a set of data and cut it right down the middle, we have the median. The median essentially divides the data into 2 halves. There's a lower half. Those are the data points below the median. Then you can take the lower half and find its median. So if you just look at the lower half of the data as a complete data set in and of itself, then you can find the median of the lower half, and we call that Q sub 1. Q for quartile. That's really the first quartile of the data. What we're doing is we're dividing the data into fourths. So Q sub 1 is the first quartile point. It's the median of the lower half of the data. Then we do the same thing for the upper half. We take the upper half and we find the median of the upper half and call that Q sub 3. That's the third quartile. Why do we go from 1 to 3? Because technically the median is the second quartile. We just don't call it that, but it is. So the median is one number in our 5-number summary. We take the lower half, find its median. That's called the first quartile. That's the second number. Then we go to the upper half, find its middle, chop it in 2. That's the third quartile. So we have 3 of our 5 numbers. The other 2 numbers are pretty obvious. The lowest number is called the minimum. That's our 4th number. And the biggest value is called the maximum. So those are our 5 numbers. The minimum, the first quartile, the median, the third quartile, and the maximum. Those numbers form the 5-number summary. Let's look at an example to see how this works. Suppose I give you a list of the ages of presidents when they assumed office between 1901 and 1993 and ask you to find the 5-number summary. Well, here we go. I'm not going to read them all, but those are the numbers and they've already been put in order. You have to have these numbers ordered before we can do any of this. First thing you do is find the median. You chop it in 2. There are 1, 2, 3, 4, 5, 6, 7, 8 numbers to the left of the median and 8 numbers to the right. So 55 is the median. Then you look at the lower half and find its median. So just looking at the lower half, you find that there are 2 numbers in the middle. We'll just leave it as 51, 51 right now. We're not going to do anything with that yet. But whatever that median is the first quartile value. Then we go to the upper half and do exactly the same thing. And this time we find that there are 2 numbers in the middle, 60 and 61. And those 2 numbers will give us the third quartile value. And of course the minimum number is 42 and the maximum number is 69. So if we want to write the 5-number summary, we start out with the minimum. Then we go to the first quartile. Obviously, when there are 2 numbers in the middle, you average them. Well, if you average 51 and 51, you get 51. Then the median is 55. You add them up and divide by 2. So you take 60 plus 61 over 2. That comes out to be 60.5. So that's the third quartile value. And then the maximum is the 5th number. And voila, you have the 5-number summary. That's the minimum, the first quartile value, the median, the third quartile value, and the maximum. 5-number summary. Very straightforward. So what we're saying is those 5 numbers capture some essence of the value of the whole data set. We're always trying to summarize our data. You might have 10,000 data points. You can't just hand somebody 10,000 data points and say, here's your data. You're trying to capture something about the data without displaying it all. Now we can actually visualize that even better with something called a box and whisker plot. A box and whisker plot is a visual way of showing the 5-number summary. And it's very easy. All you do is draw a box. If you think about your data points on a number line, think of a number line being down here. You draw a box from wherever your first quartile was to wherever your third quartile was. So remember, our first quartile value was 51. So up above here we start a box that begins at 51, and then we go to our third quartile value. Remember, that was 60.5, so that's right about there. So you draw a box that ends at 60.5. And once you get the endpoints left and right, you just finish making a box out of it. And you've got a vertical here at the first quartile. It's just the left side of the box. You've got a vertical here, which is the right side of the box, and you typically add a vertical at the median. So that box is the first thing you do when you're doing your box and whisker plot. You start at Q1, you end at Q3, and make a box out of it. Then you add the whiskers. It's like a cat's whiskers. The whiskers go from the left side of the box all the way back to the minimum value, which remember from our problem was 42, and from the right side of the box to the maximum value, which remember from our last data set was 69. So the box is kind of the heart of the thing, and then the box has whiskers. The whiskers extend out from the edges of the box till they get to the maximum value on the right or the minimum value on the left. And that's called a box and whisker plot. So this part right here, this is the actual box and whisker plot right there. The number line is just a drawing aid. It helps you see where to put the whiskers and the edges of the box. That's just a visual way of seeing the 5-number summary